I'll start with the introduction. I all welcome you a lot in this second webinar of DATEX II, and the theme of today is the sharing achievements. And we've done a lot of work in the last 2 years since the DATEX II forum in Utrecht 2 years ago. And that results in a new version of DATEX II, a new subversion, version 3.1, that contains a lot of updates in the of the content model, and we are going to walk you through them, show you what the current state of the content models are. And a very big achievement has been accomplished as well with regard to the exchange standardization. We have content on one hand, and we have the way how to transfer this content and how to collaborate between traffic control centers. We have a lot of work done in that, and it's going to be very interesting to see how in a standardized way DATEX II is supporting these the use cases of information delivery and collaborating ITS services. And this all will be brought to you by a team of experts. And I have the pleasure to introduce you to Fabrizio Paoletti. He's working at Autostrade per l'Italia, and is their head of or responsible for the ITS standardization work. His main concern is in the VMS publications and the exchange standardization today. Then we have from Sweden, a few thousand kilometers up north, Jonas Jederberg. He is responsible in Sweden for the implementation of the DATEX II nodes in the Trafikverket, and he's working for a private company called Viati. Long-time expert in DATEX II as well, and today he will address especially the new tooling and the new exchange or the new encoding mechanisms of JSON and other features. Then we have Ian Cornwall from Scotland, working for Mott MacDonald, supporting Highways England for the DATEX II implementation. He is the custodian of the entire model, so he is taking care that we don't do stupid things in terms of coherency and quality of the model. He will introduce us into the new parts regarding road traffic data. And last but not least, we have Jörg Freudenstein from Albrecht Consult. He is a German consultant supporting the BAST, the German Bundesanstalt für Straßenwesen, the Knowledge Institute of the Federal Road Operators in Germany. And Jörg will also introduce us a few new things, and maybe the most interesting thing is on his to-do list. It's the introduction or the sneak peek into version 3.2, which will be released by the end of this year. Again, welcome to all of you. I see we have 64 attendees now, which is a really nice crowd to address, and I'll give the floor to Fabrizio to the first content session about exchanging DATEX II encoded content.
Hi everybody, thanks Bard, and welcome to the second day of webinar DATEX series. Start sharing my screen. We talked now about the exchange specification. Last session, webinar, a lot of information have been done about the modeling strategy of DATEX and the fact that we have two kinds of specification. One is for payload content from road traffic data, The second part is how to exchange this content among traffic management or traffic information center. This is the vision that we have in our world of ITS. We have a traffic management center. We are responsible of managing the road, which hold road and traffic information from the management center itself. Then there are a lot of other actors in this domain, which are national access point, meaning the single national point where all information is gathered for all purposes of ITS services delivery, as well as traffic information centers and service providers who provide ITS services. The information, besides the road traffic information, traffic management center do the traffic management. So they have function to make traffic management, such as operating VMS, managing road closure, road operation, and so on. So while the traffic information center and service provider hold mostly the information delivery. So ITS services for traffic information services. Normally, we could see that the information is delivered to the NAP, National Access Point, that hold for to deliver to other actors to deliver the services themselves. This is a simplification, it's an assumption, but also the NAP may deliver services, and also there can be other kind of interchange, but this is a simplification on our side. But it's not ended. Other traffic management center may be of interest because neighboring traffic management center could exchange their data each other, and mostly for information purposes, but, and we have now a yellow arrow here, we can take decision together. Traffic management center may exchange information, and based on the information, help each other to better enhance the network management and take decision together. And this is a support also to the information processing that can be delivered in the services themselves. And then also the other possible connection are possible. So as you can see, the exchange of data is very dense, and besides the content itself. The objective of the information exchange about sensor is information delivery. So share the information on the road information which is currently active to inform the user, but mostly to give them, to share this among actors which operate in the road to implement collaborative traffic and road management. And this will deal with the exchange specification. DATEX II specification set refer to encoding payload, as we said. And this is very easily shareable as an XML file on HTTP server. That has been the most basic exchange specification available since version 1.0, the fully complete and totally functional exchange specification. HTTP GET of a XML file where all the valid content is delivered in any message. This has been retained in exchange specification from version 1 till to the current, the release version 2 last release. It is an easy and robust way of exchanging information, but there is a lack of requirement for all use cases. So there is no error management, there is no session management, no bandwidth saving, timely delivery may be argued depending on the polling rate of the HTTP GET. So this DATEX II exchange specification also contains some push and pull SOAP web services specification, which were not totally working. We missed the realigned synchronization that had been solved by individual implementation and not by harmonized specification. And then we added, there was further requirement for the traffic management use cases. So you can find more information about this in the documentation portal at the exchange rationale part. Now we release the Exchange 2020 specification, which fully accomplish all the requirements. These are based on several exchange patterns, so snapshot pull, simple pull and push methods are available, used for separate distinct business scenarios, which are the information delivery and collaborative ITS services, and which has been standardized by SENISO with support of our organization in two technical specifications, SENISO, TS for the platform independent model, methodology and general architecture, and the web services implementation in TS 148274. We had a release in 2018, which we named Exchange 2018. Be aware that those specifications are deprecated. So this is the model-driven approach we follow in Exchange modeling. We start with business scenarios, which are information delivery and collaborative ITS services, and we define a general platform independent model based on defining the requirements, defining the features which may be implemented by specific technology in an abstract way in exchange pattern. We have the exchange pattern themselves, for instance, push-pull, the interaction among supplier and client as described about interaction methods. And we take this together to define a set of features which may be implemented by an exchange pattern. This is described at a PIM level by UML, by interaction diagram we will show later. After the description of a platform independent model using an exchange pattern for implementing requirements with a set of features, we will mapping the technology to the specific chosen technology, our abstract high-level specification, deriving the final technical specification in a platform-specific model. These are examples of requirements and feature enabled by the features. So stateless, sessionless exchange versus stateful and session managed exchange. Snapshot update versus delta update, incremental update, only exchange updated information. Implementation cost, supplier side or client side. These are all the set of requirements which are listed in our specification. And how do we do the exchange pattern selection? We take also into consideration the operating mode. We have pull, that is client initiated. The client retrieves data from supplier. The push is a supplier initiated. The supplier delivers data to the client. And then the update method is relevant. We have a snapshot update, which all available information is always delivered to the client. Incremental update when only updated information is delivered. Having in mind these, the selected exchange pattern and feature functional exchange profile, which are used and described in DATEX II, are this list: snapshot pull, snapshot push, simple push, stateful push for information delivery, simple CIS, stateful CIS for collaborative ITS services. These snapshot pull and snapshot push are very simple and stateless. pattern. Most are sessionless because we don't need to manage the session until we have specific needs. We have a snapshot update, of course, for the first two, and delta incremental update with explicit synchronization, which require explicit synchronization in the other exchange pattern. So this is just a general framework that we understand the complexity increases from the snapshot pool to the stateful part of the diagram. But the features are increasing as well, so more functionalities are available and let the exchange do much more things. And there is also a bandwidth saving in doing incremental update besides the snapshot delivery. How to choose about the different functional exchange profile and exchange pattern that we provide? We have a vision on the exchange guide depending on the use case for which the delivery is done. You can choose simply snapshot pull and snapshot push when you have to deliver, for instance, the traffic sensor for standard or real-time processing. For standard processing. If you have more need of timely information, you could use a push and snapshot and delta update. But if you want to deliver, for instance, traffic management information to raise a traffic management operation, you need to go to the stateful and simple or stateful CIS for better management. Let's go how we do this in the specification. We describe the system by UML model. In our system, there is for exchange information delivery, there is a supplier system and a client system. And there is an exchange within which makes the supplier part and the client part of the exchange. This is modeled more precisely in UML as a system, as an exchange agent, the exchange agent as an exchange interface. The interface defines how the interaction is implemented among the client and the supplier. This is the TCC, or the Traffic Information Management Center system. So, in a general way, for the supplier and for the client, we have this specialization of the agent and the interface. This is the snapshot pull. The snapshot pull is the simplest method where the snapshot pull client invoke a method which is available on a snapshot pull supplier, which is pull snapshot data. So our system, through the agent, the client agent, through the client interface, which is specialized as a snapshot pull client, makes an invocation to a method with no parameter to retrieve a message container data, which is based on which contain the information. The sequence diagram is shown the interaction among the two parts, the snapshot data request and the message container which is delivered. The information that are defined by exchange specification is all contained within this model about the snapshot push supplier and client interfaces. This is the more complex, of course, simple push, which add the put snapshot data for retrieving to deliver the put data as a snapshot, or the put data for incremental delivery, and the keep alive for the link monitoring features. So, not going through these, but this is to understand how the modeling describe these interfaces. And the sequence diagram is more detailed as well, as we can see. Even if the simple push makes a very easy push, to put data through the message container to the client. But these state diagrams are describing the state of the client and the supplier exchange interfaces, and these are used to define the interaction as well as the sequence diagrams. So all the functional exchange profile which are described use sequence diagram and state diagram to well understand how to manage the different situations during the exchange and shaking. We now have to see another part that is very relevant to our exchange specification, which is the basic exchange data model. We need an exchange data model. Data supporting exchange feature are needed. And so we need, besides the payload publication, an information for storing the exchange information data. This is done through a message container wrapper, which includes payload publication, and in this case we choose to have more than one payload delivered in a message, but we have to add also exchange information as first, which we will see later, and information management and collaborative ITS services information as well. This model has been designed through the same DATEX II modeling methodology, which is able to derive XSD schema as N.1 JSON schema for exchange. So the DATEX II methodology compliant. Exchange information is one part of static information or dynamic information. We will see static information about subscription and dynamic information about the return status for managing handshaking. Information management is supporting the information update management. If we have an information delivered by push and we do delta update, incremental update, when an element is no more valid, you need to deliver it via the information management as closed. Closed or cancelled elements are delivered through the information management section. We also have, as you can see, the data, the basic exchange data model is more, contains more data than necessary for the different exchange pattern. So we derived a few exchange data profile, which can be used in the exchange to tailor the information to what is really needed in the different exchange pattern. And these are available on the documentation website and will be also embedded in the web tool. Jonas will explain in a few minutes. This is the last section. How do we map these for web services? We have this description of the interface, which is fully implemented in a WSDL. WSDL defines the interfaces through the port name, put data, keep alive, put snapshot data, as they were in the UML, and the type of the messages are defined as message container and exchange information, and so on for the different methods. Exchange documentation is available on the DATEX website. And there is also a demonstrator for exchange, which I don't have time to show you now, but enable to try and do the XML feed of the data exchange in the different methods selected to view how it is processed and the output received in the interaction. I think I am a bit out of minutes, but it is a huge information to be delivered. So I would pass the information to Jonas, which may start showing its part.
Maybe it's good to inform people that, especially about the collaborating ITS services, we have a separate slot in combination with the content modeling of the traffic management plan publication. That is 2 sessions from this one. Jonas, the floor is yours.
Thank you. I'm going to talk about how to create an DATEX II exchange service. So what do we need for creating a web service? Well, at first we need to decide the exchange pattern, as Fabrizio described. And then we need 3 pieces of information. We need, or modules, components. We need a WSDL file, the web service description file. And then we need the exchange schema. And then we need a payload schema. We need to plug those 3 together to get the service working. So I'm going to show you how to do this. So let's create a Snapshot Pull web service. What I do first that I go to the DATEX II documentation website. I will download the Snapshot Pull WSDL. I will save this in an empty folder that I have prepared, call it new service. So then we have the WSDL. Then I need the exchange schema. And I would use the web tool that now is updated to also include the exchange model. So here we have the exchange model 2020. So I select that as a source. And I click next. And now I have prepared a profile of this for a snapshot pull. So I would use the selection, the load feature to load the selection file. I have prepared. And then I click next. The profile steps now is not important for this exchange model. So I will go directly to step 5. And here we can see the content of the exchange model. And you can see that I have profiled it a little bit. I removed CIS information and information management. And then I move on. And of course, I use XML in this case. So in step 7, this schema is generated for me. And it's just 2 XML schema files, the message container and exchange information. I will copy those into the same folder as the WSDL. And then I need, of course, the payload schema. And I could do the same, go to the web tool and create my payload schema. But I have already prepared that, so I have a payload schema here, so I won't do that. So we copy a payload schema into the same folder. So now I have all these 3 parts. And I think we can look at the WSDL in XML Spy. You can use other tools, but XML Spy works great. Here I can choose to validate. And if it's green, then it's fine. So all things validate now. And we can see here the XML XS import that the WSDL includes the payload, the exchange schema, message container and exchange. So if you have this stored in another place than in the same folder, you have to adjust this path. But since I store them in the same folder, I don't have to adjust the path. Same for the exchange schema. If we look at that, we can see that it actually imports the payload schema. You can see the XS import here in the same folder. So now we have all the three parts, and we have verified that they are correct. Then what we can do is that we can create the working service. We're using SOAP UI. And I prepared a mock service that actually is running now on port 8088. And it will respond with a XML message that I have prepared. So I can change something in this so you see that it actually is working to Norway in country. Then I would take a project here that I have prepared. I will add a WSDL. I will point to the WSDL that I have created. This one, Snapshot Pull. And then it will generate a request. Here is where you can also tell it to generate a mock service, which I have done earlier. But for now, I just take the client, you can say. And now it has prepared a request for me. And since this is a snapshot pull, it has no parameters, so it's empty. And I should just point to my running server here, which is this URL. I will copy that into. And I can execute this request. And I get the response back. And you can see that it's Norway. And here I can validate this message against the WSDL and all schemas, both exchange and the payload. And it validates OK. Here you can also validate that it conforms to web service interoperability, for example. So that's an easy way to test and build a DATEX II web service. So that's it for this presentation. I think I move directly on, or should we take questions first, if there are any?
We have no questions currently, Jonas.
Yeah. Then I take JSON directly.
Yep.
So DATEX II and JSON. We had JSON now in DATEX II since version 3.0. And last year we did an update, you could say. So it has been proved to work and enhanced a little bit. The JSON mapping is built on the same methodology that we have in DATEX II. So it's just an additional PSM. So now we have XML and we have JSON, and there is also an ASN.1 available. The mapping for JSON is included in the PT710TS, Intelligent Transport System, Urban ITS, communication interfaces and profiles for traffic management. They had a need in that project, so that's why it was included in that specification. We have used the DATEX II, we have used a JSON in the DATEX II Lite with the web app and the data feeds for the app. So as a test to prove that it works. In that case, it was lighter models, but it works fine in the huge model as well. The mapping is available in the tool, so you can use the tool and generate the schema. And I'm going to show you a little bit about that, but we take that later on. Some remarks on JSON. Well, it's not included in the DATEX II CEN EN 16157 series. JSON schema in general, when it comes to validation, is more relaxed and forgiven. You can say the order is not that important in JSON. And it's based on the JSON schema draft version 4, draft 4. There are newer ones available, but we're still at draft 4. So now I'm going to show you a little bit how it looks like, the JSON schema. This is the JSON schema that I have generated from the web tool. And you can see that as in XML, it's a file for each namespace. And if we take a look at one of these files, I use XML Spy here as well. And you see that it's, well, it's JSON, it points to the schema. And here we say it's draft 4. And we have the definitions for this namespace. So this is common. Yeah, not much to say. It's a JSON schema. We can look at an instance of this JSON schema. I do that in XML Spy as well. And here I have selected this, the D2 payload.json as the schema. So now I can validate in the same way as in XML. And you see that this is a DATEX message. It's situation publication. We have situation record, accident. And we can see the accident type, for example. And you see it was green, so it validates. But if I change to accident 2, for example, it will not validate. I can also get help and suggestions for types, like in XML. So that's it that I have thought to talk about JSON. So over to you, Bard.
Well, thank you, Jonas. I think this was a very helpful introduction into the Exchange and JSON support that we have in DATEX II now. And as you might have seen between the session or the session from Fabrizio and yours, Jonas,